So I have here with me Peter, who is the founder of Percona. He will be talking about databases and the role that it plays in this AI era. Peter, the floor is yours.
Okay. Can you guys hear me well? Yeah, so we are going to talk about databases, AI, and Kubernetes, right? Isn't that an awesome combination? Yeah. Well, at least I think so. Now, I've been involved in the database market for, oh my gosh, more than 25 years now. And from all this time, I think we had this never-ending journey to see how we can build a database in a more simple way, to simplify, to automate, to reduce the toil, and so on and so forth, right? And AI has been playing an important role in this, right? If you use kind of some different terms for AI and databases. Now, anybody here heard the term of autonomous database, especially Oracle autonomous database, right? Like that's what Oracle started to use started in 2017, and then we kind of transitioned more to this idea of self-driving databases. When we speak about the database, which is kind of really driven by AI. And I think that is a very interesting and fitting term, because what that allows us is really to kind of have a parallel between the databases and cars, right? And we can talk about something like the level of autonomy, right, which exists. Like these are level five levels, right, which are defined for cars, right? And really we can loosely apply those terms to databases. Now, where do you guys think what the most databases are today, right? If you kind of use that the self-driving kind of level of autonomy. Anyone? Huh? Well, yeah. I would say it's level 2. We have some systems getting into their level 3, but I think it's interesting to see what we are still pretty far from complete autonomy. Now, I also a few weeks ago did a very scientific poll on LinkedIn. Right, and ask the people what is their trust to the modern AI, and how much of them would trust the AI to run the database completely. And as you can see, well, that's actually was like surprise to even to me. Like only 5% are kind of trusting people. I thought there would be more than that, right? That's kind of correspond, I think, to that reality. What while we still we have continuing and increasing the way what AI can do in terms of the databases, it is still pretty far from a total automation. Now let us bring the Kubernetes into the picture. And why do I think the Kubernetes in particular makes this kind of like a great platform for smarter databases, for self-driving databases, wherever you would want to call them. And I think this comes from several properties what Kubernetes has. One is Kubernetes is pretty much ubiquitous, right? You can run Kubernetes anywhere, right? There's a managed Kubernetes pretty much every cloud vendor. You can run it in your data center, in the edge, on your laptop. You can run on large devices, small devices, and so on and so forth, right? And that I think it gives us saying, hey, if we learn how to deal with databases on Kubernetes and automate them and apply AI, right, we can really have a very, very broad set of environments for us. Then you can also see where Kubernetes being well defined, or at least kind of relatively well defined, right? You can, of course, set up Kubernetes in a very, very many different ways, but if you think about that, it's still much more constrained compared to your normal kind of way how you can potentially run a database. You can install any kind of number of operating system. You can use different packages. You can choose to, run the databases compiled from a source code. You can set up high availability in a ton of different ways, right? And that is what creates a problem, right? Then if you want to say now, I can take a database which is kind of already deployed and try to have AI to reason about that, that becomes a very, very complicated because the possibilities of how it's done isn't endless. And the third item, which I think is very important, is it is really programmable in very many aspects, right? For example, in a database, one of the things which we need to do is to have a self-healing. If a node dies, we need to make sure we can, bring it up, right? And for that, we need to make sure there is a sort of, let's say, programmable interface for that other node comes, and becomes available, right? If I am operating, just a classical bare metal data center, if my server dies, well, what, right? I need kind of to figure out a way, to provision another server, and that may require hands, even if I have it available, and so on and so forth. But I think there are also the reason why you need the AI specifically for Kubernetes, because Kubernetes is also more complicated, right? Kubernetes is much kind of high-level abstraction compared to your bare metal and even virtualized installation, right? It runs kind of on top of that. It has many different components. It's a very kind of dynamic environment, right? If I have a database deployed on Kubernetes, right, and left it out there and came back, a couple of weeks later, it may be different. Some pods may have moved, and some other things may just happen. Compared to again to your bare metal environment where I have, say like a free physical service in a high available cluster, and it's going to run this way for years. And that means I, as a human, can set it once and kind of really know how it works, and it's not changing. That is not the case with Kubernetes. And I think now which is a very important part why we need things to be adaptable is what we do have more tendency to over provision in Kubernetes, right, which drives cost. And for reason is because that is easy. It's very easy to get more resources in Kubernetes in majority of environments compared to, again, that case when you actually, if you need another server, you have to kind of, rack it, right, again, in the 20 years old already. Now let's talk about the databases and artificial intelligence and how do those things play together. I would say if you put it in a very two big groups, that can be either related to the database usage, right? And this is may come from analysts writing report of database, which can do it with the assistance of AI. That's maybe your developers writing applications which use AI for schema generation, for queries, and so on and so forth. And then the other aspect is, hey, we have an existing application, right? Well, it's maybe fixed, it uses database, and then that database needs to be operated somewhere. It needs to be kept up, it needs to be backed up, scaled, patched for security, and all that kind of stuff in database operations, right? In this talk, because that's where most of my background comes from, we are going to talk more about their about the database operations. Now here is also a very interesting question about AI, which I know often comes in my environment, right? We, as Percona, specialize in database, so I have to work with a lot of very, very, so smart, some of the best in the world DBAs. And they often can say, well, guys, I can do things better than AI, right? But then if you look at the reality for a lot of developers in many organizations, they don't have those skills, right? And the question becomes, I think in a grand scheme, is not wherever the best human DBA can do better, right? but to what extent the resources companies have available, right, or not, can do compared to the AI, and also what is an opportunity cost. In many cases, if you take even not a database expert, but you have a smart engineer who will go and spend a number of days figuring out how to configure a database, set up indexes, and all that stuff. Manually, they may even get a better results, right? But often that comes an opportunity cost of actually working on their application and pushing that forward. Now, let's think about the database problems. What do we have to deal in that landscape of database operations? Well, one is spending more than you should, right? That corresponds to this kind of like a performance and cost that often come together. Because if you're not really running an optimized database environment, often you can still work, but it just takes much more money. Performance is important because if you look at the slow applications, that means users are not happy. Typically, also that can impact your revenue, and also extremely poor performance becomes indistinguishable downtime from user standpoint, right? If you are trying to load the page and it takes 3 hours to load, well, maybe it technically loads, but you're not there to wait for so long, right? And then the other one, which is specifically marked in the red, is data loss or data exposure. Why I mark this one is because a lot of other problems can be fixed after you spot them. Let's say, oh, you know what, my database became overloaded. Like, well, yes, maybe kind of my site was slow for an hour or a day. Well, then I fixed it and it's fine. It's not a big deal. But if you find that your, all your customer data, downloaded and now available in dark internet, you can't really fix that, right? That's a very prominent things, and that means in that area there are really mistakes are not allowed. The other thing, I think, when we look at in particular worry in terms of where we want to deal with AI is a lot of things in databases, they also require some sort of human level decisions, trade-offs. Like, for example, how we want to deal with a fast versus correct, right? Or, think about, for example, deploying caches. Caches give us a stale result, technically incorrect, stale by a few seconds, but for many applications that can be okay. But for example, giving you, cached bank account statements, values, right, would not be appropriate, right, and letting you kind of to spend the same amount of money multiple times. That is something which requires understanding business logic and human level decision. Cheap versus reliable, fast versus reliable, right? There is a lot of those trade-offs, right? Which we may take those decisions of AI systems, but at least we need to give some guidance. Okay, let me speed up a little. So if you think about the AI, where we are looking at where it can help us, there is this number of areas of concerns, right, where we can really use it. The first one is environment, right? An environment is, how many nodes we deploy, how we configure storage, network configuration, and so on and so forth, right? If you look at those choices, significant amount of them is still taken with, I would say, human input. Then the area which we can control is Kubernetes and operating system configuration. There is a lot of different knobs and choices you can make in this case, which impact the database performance quite substantially. And we can see some of those items are being, controlled with AI better than others. The third sort of area would be the database deployment modes in the Kubernetes. Kubernetes allows you to, for example, take the container and deploy that on Kubernetes, and that's maybe okay for testing, but that is not great for production workloads. For production workloads, you want to use operators for deployment. And I think what is interesting is for a lot of popular databases, there could be multiple operators which exist. Probably the most popular database for new deployments, Postgres, right? I think it has at least 5 different operators which exist how to deploy. One project I want to highlight here is called OpenEverest, which is a newly CNCF sandbox project, which sort of builds abstraction on the top of operators and gives you something more like Amazon RDS experience, right, with graphical user interface and API, which is backed by Kubernetes and operators in that. Now, database configuration. Database has a lot of knobs you can play. And if you think about approach to those knobs, can be in 2 ways. One is, we as a human would often say, knowing our application and knowing kind of like the scope of a node, we can tune parameters, how much allocate the database cache, maybe some other stuff, and have this kind of like a static configuration. But I think what is interesting in this case is what with AI, we can actually constantly adjust the configuration as needed based on actual workloads. And that can give you some additional boost. Depending on the workload, it can be quite significant. And I think this highlights this very interesting case of where in some cases the AI tools just allow us to do certain things it's not practical to do for a human being. Right? Just say, you don't want to go ahead and retune your database settings every day, right? That just does not make sense. While AI can possibly can surely do that. Here are a couple of tools I wanted to highlight which help us to do this. Like Releem is a tool which does automatic settings and queries tuning for MySQL. DBtune is an awesome tool to do settings tuning for Postgres, right? And there are some others as well. Then the next thing which we can look in terms of optimization of databases is schema and various storage parameters, right? You can have, if you're using MySQL, for example, there's different storage engines you can choose, right? And that applies for some other database engines as well. There's also choices like how do you design your schema? How do you deploy tools like partitioning, right, to make your schema more efficient? How do you deploy indexes? From this sense, I think that indexes are the ones which are the best covered by AI tools those days. There are a number of tools which take it in the context of query optimization, right, which would advise you on indexes. Releem is one of the tools I mentioned has that feature. pgAnalyze, that is another very awesome tool which allows you for automated index tuning for Postgres, and also Avian. They bought a company which is called EverSQL, and now it's integrated in their service as well as they have this free SQL optimizer which can give you advice on query rewrites as well as index changes. I very much like index impression because it does not require application modification, and that means often people on the database operation side, they can make those choices independently without waiting for the development team to do some query changes, right, which can take longer time. Then there is a scaling and cost control, right? In this regard, we can say that after scaling existed for a very long time, right? In this case, and the good thing of Kubernetes is that is pretty easy. My take of that is also to approach the scaling in a way that make sure your system is well optimized and efficient first, and then scale. Because in our case, especially if your system is very easily scalable, like you have a sharded or natively distributed database, you often can scale that to be very, very big, very inexpensive, and very expensive, and very big and very inefficient and expensive. Some of you may have heard the horror stories about somebody running, query with a Google BigQuery and getting, $10,000 bill for a single query, right? Well, that is one of examples, right? How we can say, yes, I can run a query, I even get results back, but it's so freaking expensive, right? You may not even want it at all. Next, the application architecture. There is a lot of things that we can look here, and I think when it comes to the application architecture, that is mostly in the hands of humans. Of course, if you just go ahead and sort of like a wide code the application, it will probably have some, trivial architecture which is selected for you, right? But if you're looking at really large-scale, mission-critical production applications, typically humans are significantly involved in that architecture right now, right? And maybe let some lower decisions for you. Finally, let me cover some of those requirements for AI use, which is important. The first one you may often hear in terms of AI, it is the context, right? Garbage in, garbage out, right? And that means if the AI doesn't really have the right direct information about your environment, even if it's kind of awesome and the most smart ever, it won't be able to provide you good information. Some interesting tools to mention here. One, I would mention the Coroot. The good thing about that is it's able to build the model of your environment and applications very easy without a lot of code changes. And if you look at the database specific tools, I would highlight those few tools which are awesome extensions for Postgres, which can either capture a very fine-grained data, or with HypoPG, it allows sort of AI to experiment safely, right, in terms of how different indexes will impact execution plans without actually doing an expensive job of adding indexes and dropping indexes. And the last one I would touch about is this keeping things safe. You already have seen in the early slides, only 5% are ready to trust AI right now, right? Why? Because the databases are so mission critical. And we know AI makes mistakes. And the thing is, right, even if it's only makes mistakes in 1% of the time, right, well, it's not good enough for databases. And what that means, I think, for database, we are going to look into how we can implement appropriate policies so we can decide what AI can do independently in managing database, where it needs a human advice, and which things is just simply forbidden to do, right? Like, hey, guys, you know what? Hidden all that kind of expensive replication will make things run much faster, but you know what? You cannot do that because we obviously need database to be available. So let me finish by those things. Now, if you think about this AI DBA stuff, right, or self-driving database, whatever words you want to use, I think in the end it's going to be, inevitable for most environments, right? Yes, it will take us some time to get there, but increasingly we'll be pushing more things to AI because it just makes sense. I think for now, if you are a DBA, I would encourage kind of your human DBA, right, yourself, and AI DBAs to sort of become the next friends, because best friends, because even as it is right now, AI, while it may not be ready to independently manage your databases, it can really makes your job much faster and more efficient. And that's all I had. Thank you. Questions? Okay, yes, questions. I'm permitted to answer some questions.
You mentioned a couple of tools,
Yeah.
but have some say, can maybe give some recommendations. Tools for using the EverSQL, something for EverSQL.
Microsoft SQL.
Yes, so.
Yeah, well, I'm not expert. My job is usually advising people to move from Microsoft SQL to something better, right? So,
Hi, thank you.
are you going to ask about Oracle? Then answer go to the same.
No, but I saw like almost all, I don't know if that is like that now, but almost all the tools you presented are most focused to the relational or DBMs and not more than NoSQL database.
Yeah.
Is you see some complexity to do that or not?
No, I mean, look, not really. I think the same things applies to their NoSQL databases, right? I think it's if you look in this case, there's a lot more, I think, tooling being done for relational database, and I think a big reason for that is because the SQL is a standard, right? And so it's pretty ubiquitous, right? So you have this like people doing like text to SQL conversion, right, for example, or how you can, build a model for SQL queries and, rewrite it and so on and so forth, right? A lot of research and some standard where if you look at, for example, MongoDB language, it's kind of only one vendor, right? So who less, right? And I think another reason is also the complexity of that queries in SQL is usually much higher, right? Because if you think about something like, like a key value store, right? For example, there's not both like a complexity which requires.
But because you show in one slide like all the tasks about this schema, so I mean for that.
Yes, well, I mean, again, I cannot answer this question. I think in MongoDB environment, right, they have some tools also to assist developers with AI, but I didn't look much into it.
Yeah, thank you for the talk. It was kind of philosophical, so I have a kind of philosophical question as well.
Ooh, okay.
Yeah, so if we are speaking about DBA and if we are speaking about AI engine for DBA, where is the place to locate, like this piece of software that integrates with the AI? Are we speaking about control plane that, the project you provided? Are we speaking a part of the database? Are we speaking about, where is this?
I think that is very good, a good question. Right? I actually had like a different talk about that in architect, right? Because if you think about how to have that AI and database, it kind of comes in two parts, right? One is what we have right now is there is a database. Let's say we have like a Postgres, and then there's going to be AI control plane, right?
Exactly.
Side pattern is going to to change the settings and so on and so forth, right? And that works very well because you can have an existing, very stable, mature database, right? And just work with it. You don't need to change the database core, which is classically has been slow and risky and so on and so forth, right? There is another way we can say, hey, how can we actually design the databases, right? So they will have that in its core, because actually inside the database, that is where you can take the best decisions. You can take decisions in real time. You have the best access. You have all information. While information for external control plane is always kind of delayed. It's not so fine-grained in its limit, right? And I believe there will be more and more AI built in a database kernel, but it's going to take time. So, right? But that will give us like really, better results.
So the answer is that we do have it in the control plane already for some things, and we are on the verge of new SQL releases that we will have another generation of databases or new version of databases with AI baked in.
Yes, I would believe that we'll have like much more algorithms, right, which are more kind of adaptable, right, and using it. You can already see that in such cases, right? Like, for example, some of the commercial databases, they have optimizer for queries, right, which is a sort of like AI based rather than sort of like more like a classical, which is based on a host model, right? Like, Postgres, MySQL, right, as a
Okay, cool. Thank you.
That's very inspiring talk. So the question is about data lineage. So we're dealing with structured, unstructured medical data in the hospital, and we are moving from traditional warehouse to the lakehouse. So how do you think about in the age of large language model we deal with the data lineage and auditing?
Well, and the question is
about data lineage.
Yeah. So, well, again, I think in this case, that is a whole sort of like another universe, right? Or at least kind of a space. There are some, good tools which allows you to track the lineage, right? And AI tools, for example, which can flag quality problems in data lineage, right? Like some and some other issues, right? And I'm sure, right, the AI will probably is already used in that case. I just don't have a lot of insight. Yeah, sorry about that.
Yeah, thanks a lot for your talk. So the topic is about like a suggestion conflict between the AI for the users and AI for DBAs. So basically, what can happen is AI can suggest to user to increase the resource utilization of a query, adding changing some parameters. On the other hand, DBA wants to manage the DB of the resources itself to reduce as much as possible, right? So in this sort of scenario, and there could be other scenarios where there can be conflict on the AI suggestion on both sides. So how do you see it?
Yeah, well, what I would think in this case, right? I mean, you're talking about their sort of a person, right? I'm mostly talking about the tasks. And if you think about, in most cases, there is some sort of overlap, right? Because in this case, you're saying, I, as a user, I'm going to go and change the database settings so my query runs faster, then that means you're actually also getting into the database operation tasks, right? Like in this case. And that becomes sort of not so much like a technical question, but I think more like an organizational question. Hey, to what extent you're given permission to do so. In certain cases, right, you often have, just one developer, and he does both database operation, database development, and he is responsible for everything. In our case, there is much more separate. Hey, I have my operations team, right, and developers, they only can, run the queries, they cannot change any database options. Okay. Right, so that is how it's, constructed.
So let's say more like the organizational problem, how to segregate the
Well, but that's right. But I think what you're saying in this case, and that is it exists, I think, even now, because if I'm saying I see the same system and have a different user of that system using different tools, and those different tools, or even different experts, come up with different recommendations, well, in the end, you need to recognize those opinions, expert opinion or AI opinions, right, and figure out what you're going to do. Right, that is sort of again like an organizational choice about how you make those decisions. Right. I think the challenge with AI now is it's very easy to get variety of decisions, right? They can go to like 5 different models, ask a question, and they're probably going to get slightly different different responses, right?
They also have like a different profile of like an AI, AI DBA, AI like a query optimizer.
Well, yeah, that's right. Okay, well, thank you.